Okay. All right. Welcome. Happy New Year, everybody. I think this is like the second to last day I'm allowed to say that. and then and then it's not the New Year anymore. So we've had a lot of PRs merged since last time, and graciously Jeremy has started to pull these together into little buckets of work streams, so that things are sort of organized. So one work stream, I guess, that we've been working on has been performance improvements of the compiled program. So this is the runtime performance of whatever we've compiled. So those included backend specific optimizations. So now OpenFHE's in-place operations are supported. So there's a transform that does something similar to Latigo in-place transforms. We skip over 0 diagonals in a convolution. So if any of the convolutions have like, because you're sort of packing the matrices sparsely in the filter matrices sparsely in this larger matrix, you might have 0 diagonals. Parallelization for rotation operations is also supported in OpenFHE, which happens a lot for the matrix computations, because you might want to do like, log n number of rotations for the matrix. And then sort of a performance improvement, but during the pipeline, we fixed the bootstrap depth, which I think might get ignored by OpenFHE anyway, but now we use the OpenFHE API to get the bootstrap depth, which gives you like the accurate number given your level budgets and the bootstrap depth for that key type. All right, I think that's it. Okay, so and then more to come, obviously. And then compile time improvements. So this is improving the compile time of HEIR for the program. We are working on loop support, which should make the IR size much more compact. And I think the issue is linked, and then there's a lot of PRs about this particular part. And then there was also a small performance improvement by using a heuristic to check if 2 relations were equal instead of doing like a very expensive large quality check. And then the other major part of what I've been doing has been splitting the plain text pre-processing out of the main code. So this has been asked for, I don't know, since the beginning of HEIR to do this. Hardware accelerators might be interested in this sort of thing. And I will say that, so there's a number of PRs listed under here to get that support. So now we split a main function and we gather all of the encoded plain text into a pre-processing part where all of the computation needed to compute those plain texts is done there. And then you pass those plain texts into the processed, like plain text processed function, which just contains the ciphertext workload. So there was like a number of small things to do there, but you can see in like in the PRs and the doc tests about what those packing functions look like. Some caveats, I think, is that the end-to-end support only works for C++ code gen right now, because you might not be able to code gen multiple return functions for every backend. But yeah, TBD on adding more support as people ask for that kind of stuff. And then on some benchmarking stuff. So Jeremy and I have been working on getting comparisons with the Orion compiler and the Halo da Capo compilers. So there was an Orion to Latigo conversion in here, and then also, oh, right. Okay, so we also have like a collection of places where we can get the Orion outputs into MLAR, into this Orion dialect, and then also the Halo output as a CKKS directly. So that just works from CKKS onwards. And then we have a Linnet CNN model end-to-end in that PR, but it takes a very long time to run. I think the compile time is now something like under 2 or 3 minutes or something. It's not too bad. It will run in the time that you can do something and look back and it's done. But the performance time is still fairly large, and that's why we have all this performance improvements and stuff. On front-end improvements, Alex has also been working on some of this stuff. People have been filing some issues about type issues, and so there's a couple of PRs about that on here. So keep filing front-end issues. I will say it's not super high on my radar, but people should be able to use it. It shouldn't be like glaring bugs. So keep filing issues if you have test cases. Other improvements generally, Voucher worked on the LUT generation to support LUT4s instead of just LUT3s. The bootstrap insertion process for CKKS. So I think if you had CKKS with an OpenFHE backend, we just like completely elided a lot of the management pipeline support. So we're in the process of like trying to make that better. So there's a bunch of fixes related to management and analysis to support that. And then nothing too crazy. This dense resource and OpenFHE PK key emitter. So if you have a dense resource, now we'll be able to emit that value without choking on it. And I think someone had filed an issue about that. And so this was a fix maybe to one of those issues. And then the other major work stream on IR size and like compilation and just making things easier has been the Halo loop support. So Halo style loop support. So you'll see a couple of PRs out graciously annotated with the solution numbers corresponding to the paper. So this involved making type matching happen over loops. So if you have like an input plain text and then you end up adding a ciphertext over and over to it, you need to peel the first loop iteration to make the type matches. You need to make the levels match. You need to make the dimensions match. So there's been bootstrapping insertions and things to make level management happen properly with loops, and also optimize the performance once you do that, which is what this B2 solution is about. Other random stuff going on, we have an AI tool use policy. So if you use AI tools, you should probably go check it out. But like the short answer is like, please don't make the review burden harder for us. So please review your AI stuff and make things nice to review. And then there's been an ongoing migration to Basel 1. I think it's done, or maybe it's pending one more PR or something.
The last thing is Yosis and ABC, which I don't remember what the status is, but I think it's on the Basel Central Registry, and there's like one more thing that needs to happen to get it to work.
Okay, and I think there's an open issue or PR about it, about the Yosis ABC part. And other things, okay, yeah, we've been also looking at some of the analyses have had small changes. One is loop support for level analysis. That was part of the Halo loop support part. And then this range analysis as well was just a fix to make range analysis work when there was an upstream issue. So lots of movement going on the analysis frameworks. Okay, on to new issues. There have been a large collection of issues from a project that was using HEIR to demo, or like, I guess, like experiment with their automated fuzzing. So there's a bunch of issues filed about assertion failures and compile time assertion failures. From that, those are cool issues, I think, too, if someone wants to improve those support, make them better error messages instead of assertion failures. So if you're just looking for something to do, maybe you could look at some of those. And then another issue is that, so I mentioned before, we stripped the zero diagonals from the convolution computation. In those cases, maybe let's say like out of the 256 by 256, zero diagonals, only like 10 of them are non-zero and they're spaced equally, then maybe you can improve the baby step giant step ratio that we use to perform the matrix vector product. So that's an open issue. There's a couple, the GBFE scheme for HEIR. So this is that new generalized actually, is it generalized? Or maybe it's
well, officially it's generalized, but I would like to always call it Helen BFE.
Yeah.
Because we can also like just call Robin for the work that he has done for the scheme.
Yeah, so this is a new scheme, and I think short things about it is that it should compute, it should be able to support some larger lookup table sizes while still having this sort of arithmetic RLWE based, SIMD style ring structure. I don't think any compilers support it right now. So maybe if people are interested in taking a look at it, it's open. So and there was this issue is fixed. I think it was a type issue on this convolution 2D. Again, like I mentioned before, some front end issues have been posted. Another thing is our compiler doesn't really take care to distinguish between secret key distributions. And there are some places where we hard code the fact that we're using a uniform key distribution. So this is another issue describing that support. Someone has already done a little bit of movement on this eval fast rotation X over eval fast rotation, so that will compute the fast rotation and keep it in that higher basis that you might be able to perform, reductions or something in that higher basis, and save out on the modulus switch from PQ to Q after that. So I think that's already being moved on. Plain text computation strange bug. Don't totally know what this one is, but I think this is a front end bug.
I'm pretty sure that's one of the fixed ones from the type issue.
Yeah, I think Jeremy, maybe I'll make a PR to the script that created this doc, but we should maybe annotate which ones are open and closed. Then unsupported, so I mentioned before, we have in place OpenFHE ops supported now, and there's transform that creates those. Commutative ops also need to be supported, and I think also there's something where you might be able to do some in-place ops better in some places based on which op, you might be able to flip the operands and get better performance, get more in-place ops. The other thing is, I think this is an artifact of how these in-place transforms and in-place ops were written, but they have an op result, and I don't think they strictly need an op result, right? If you have an in-place op, then you can have an interface that specifies which of the operands are in place, and you don't need a new SSA value returned. I think it's just an artifact of how they were created in the first place. Noise analysis fails for a trivial program. Okay, I haven't read through this issue, but I'm not surprised. A lot of our noise analysis needs to be rewritten and or at least I don't know, more robust or something. Wrap generic. I think Alex, you had commented on this a little bit, and I think someone had started a PR on this as well to use the secret analysis in the patterns. That definitely needs to happen. We didn't have secret analysis when we wrote some of these patterns. So if you're interested, you could take a look. Because we have a lot of different target backends, we probably need to start thinking about making target specific configurations to ingest during the pipeline options and parameters that they support. Loop unrolling has a small heuristic here. There could be better ones. So you can read that about the Halo loop support line of work. In our level analysis, we don't yet consider how many levels the bootstrap op consumes, because partly, again, that depends on your target specific configuration and what sorts of parameters you end up choosing. There's a problem a little bit with a flip on the mod reduce before mul options. So in the management pipeline, there's small cases where it doesn't quite work with loop support. Another potential issue that hasn't surfaced yet, but I filed one so that we know. Right now, if you have a scalar that's layout assigned, we just splat it across the ciphertext, which is not necessarily true. There might be gaps or other things the kernel requires. But right now, we don't do any of that. So it hasn't surfaced yet. The torch MLAR compiler seg fault. This is a root cause that might be a good first issue for somebody to. Alice had posted this issue about a simple dot product that was computed, and the reduction in the dot product isn't supported yet. So we don't support the reduction kernel yet in layout, although we do have reduction kernels. We just haven't hooked up everything for a simple reduction. So that could be a good thing. And then two interesting things, MAD, the memory word design techniques. There are techniques in here for, I think maybe it's relinearization or other kernels to accelerate, and some of those techniques could be used in our lowerings at the LWE or I guess at the LWE to poly level. And then Desilo also, I think this was an issue that Muthu posted. There's nothing stopping us, I think, barring licensing issues, but I think they might be okay. But this would be a good target to add a target backend to add in, especially I think since they have GPU support and CKCast GPU support. Okay, sorry, there were a lot of issues. So I'm sorry I went through all of those, but that's a pretty much rough overview of all the fallout from all the new stuff happening. And then in progress PRs, I think they're mostly kind of continuations of those work streams that we mentioned before. I'll try to see if there's anything particular to point out here that I haven't mentioned already. I think they're really all kind of, yeah, what I mentioned before. Someone has also started working on that shift network source conflicts issue. And then, yeah, everything else I think has been continuations of work before. All right. Any questions about what we're doing or where progress is going or anything before I kind of just, we'll take a quick pause.
I think you give a great overview of like the things that are being worked on. What's the end-to-end pipeline sort of progress for the machine learning to CKKS stuff at the moment? Because I feel like it's sort of all the trees, not, you know, kind of losing track of the forest.
Yeah, right. This was a very work stream specific thing. Let's back up a little bit. So yes, all of this work has been fallouts of trying to support ML inference properly using CKKS. And benchmarking that work appropriately with the other compilers that do so. So that's the unified situation there. Okay, so where are things right now? Right now we have an MNIST fully connected, like an MLP style example, and an MNIST CNN network that are pretty good examples. I think the CNN one runs in under like 4 seconds or something with all the performance improvements I talked about. We have that Lynette example. So that's a larger convolutional neural network. We're working on improving the performance of that one to a certain degree. Let me just type up this too. So, sorry about that. So ML CKKS pipeline progress. So yeah, you should see committed examples of OpenFHE CKKS, and I think probably Latigo for some of these. CKKS examples for MNIST, a fully connected layer, and an MNIST. Oh, and a convolutional neural network. And then, yeah, in progress, but slow is Lynette. So we'll work on improving the performance of that to a certain degree. And then our next up on our scale is ResNet. And more. I'll just say that. So larger models, more interesting models there. But yeah, we really need to fix the compile time and the IR sizes so that they're easier to work with. And then the other part is, yeah, benchmarking. So we've been looking at the benchmarking to Orion, the Halo to Capo work, and we should have some progress with like comparing them to Rotom, which is Edward's from CMU's work, and some other like maybe other layout optimizers or tools we can do there. That's kind of the summary. So yeah, and then the questions, I guess, like on backends. It would be nice to have a GPU backend. We just haven't had the time to do that yet. So that's kind of on the table there too. If anyone wants to, especially, I don't know, the DeSilo stuff or something, if someone wants to poke in on that, basically if the pipeline is working, now you can take some of that CKKS stuff and lower it to a GPU backend. All right, yeah.
Yeah, I think I talked about, I promised somebody that I would eventually get around to doing the like GPU backend thing. And I think the biggest thing that's missing, apart from like actually writing the like boring bit, the emitter, is lowering larger kernels all the way down, right? Because a lot of these GPU libraries expect, let's say, a matmul or a boot, like rather than like a series of rotations and things. And so I think that's like the biggest compiler challenge to us from a pipeline perspective is, yeah, we can have a CKKS level GPU backend, but like the expectation for that will be that performance will be relatively poor because of dispatching by FHE operations just isn't very good. And so, you know, finding ways to like lower down high level kernels, that then introduces all kinds of fun questions like, well, what's the input and output layout of a matmul in this GPU library? And like, you know, how do we communicate that? And I think you already talked about, we need to start thinking more about, you know, backwards propagating information from the like backends to the compiler. And so I think like this is, I think having a GPU backend that just does CKKS level stuff, I think is a really good starting point. Also just for, you know, testing and correctness. But then from the compiler challenge perspective, it's really about passing larger kernels to the GPU?
Right. That's a good question, and I expect also that some of these if hardware accelerators that do need these bigger kernels like MatVec, I think this is the time where we start scoping some of that design out. I know we talked about this at like, I don't know, HES 2 years ago or something, but yeah, maybe now is starting to get to the time. But I agree. Yeah, we need to probably preserve some of that MatVec stuff, and align our layout analysis, or I guess we still need to do layout analysis, but align our kernel lowerings for those. Yeah, I think that's a large problem to tackle, and also we need to sort of decide on the investment level for that, and that kind of depends on hardware accelerators' need or desire to have that. Okay, anything else on that, on like the CKKS pipeline and things like that? So yeah, that's kind of currently our focus of just like trying to get that done, because that will unlock one, like being able to run these on hardware accelerators and like scaling up to models. Like forget about doing transformers if we are still stuck on, large IR sizes for a convolution.
I think one thing I wanted to mention is that we're still not quite clear where the performance gap is between what HEIR is producing and what some of these other compilers are producing. So I think for a while, like this was basically like January, right? We're like, okay, we gotta get some performance measurements, and we tried a bunch of stuff, and I think the only thing that made a dent was just pure parallelism identification. But like at this point, we're sort of incorporating all of the same tricks as all of the other compilers, but our thing is not fast enough. So we're still trying to figure out like where exactly the performance gap is. And then as a consequence of that, we're like, oh, it's taking so damn long to compile any of these examples. We need to really fix the compile time so that we can have like a faster loop on checking the actual performance improvements. So that was what led us to do the Halo stuff now as opposed to later. So if anyone wants to like work with us on the hard problem of actually identifying performance issues in our compiled models, we would be grateful.
Yep. Yeah, I will say like it's we don't know, is it OpenFHE? Like, is it the parameters we're setting in OpenFHE? And yeah, right, like Jeremy mentioned, I think with the parallel rotations, that was like the biggest speed up factor algorithmically we noticed of what we were doing. And there's still like smaller algorithmic improvements like this fast rotation X, or using fast rotation X and modding down appropriately, like pushing that further down. But we don't think those ones will cause as big of a performance improvement as the parallel rotations, let's say, did. So if anyone wants to like take a look at, the OpenFHE that's generated and see like, are we just running it really badly? Is it a RAM size issue? One thing we haven't done yet is that issue that we filed a very long time ago, composite rotations. Not that this will make the performance any better, but it will make the RAM size better. And maybe that will improve the performance if there's some throttling going on. So there's a number of things, like help is appreciated if you're an expert at making these fast programs by hand. And then hopefully we'll also be able to give you a compiled model that is easier to look at than like 7,000 lines. All right. I will move on a little bit to just like some other discussion things. So Jeremy and I have been obviously like working on some of this stuff to try to hit the Usenix paper deadline, but we are not totally hopeful we'll be able to do that, given that I think the abstract is probably due tomorrow or something. Or maybe Monday. I don't know.
Yeah. No, today/tomorrow, depending on your time.
Yeah.
But there are a couple of other conferences coming up that we are targeting. So there will, as we make progress through this, we are expecting to get something out and have some, have people be more aware of this, but it's more important to get the right stuff done. And so that's the big focus. So again, anybody's help, deeply appreciated.
Yep. And then I will say also that that's like going to be like, that was intended to be sort of a HEIR white paper thing. And this doesn't like distract from the fact that there are other papers opportunities to make with like special research in there. So definitely we're looking at that this year as well. The other sort of like logistical thing is that Monday office hours has been shortened from an hour to a half hour because we decided like we were just kind of like dilly-dallying for the last half hour anyway. But that being said, if you want to sort of guarantee some kind of time or you just can't make that 30-minute slot, we have bookable slots on the calendar. So go and, schedule a bookable time and that'll set up like a calendar invite, and Jeremy and I will probably be there. So if you want to talk specifically about a certain issue or scope a certain issue, we more than happy would love to do that in office hours. And I think it's usually a pretty productive time. The other thing I mentioned before is the AI tool use policy. That's on the website. Definitely check it out if you're using it. But yeah, just use responsibly.
I can say something about that. The reason for this was because basically anytime I create an issue I tag as good first issue, within 12 hours, some Indian student will post a thing saying, please assign this to me. And then within another 6 hours, there will be a PR that looks like it's completely LLM generated, posted to try and fix it. And usually they're not very good. And I for a while, I thought it was like maybe like people trying to like build up malicious actors trying to build up profiles of like good open source contributions in order to like later place a vulnerability in some critical system, right? Kind of like a supply chain attack. But then I looked at some of their actual, like one person who recently did this, I looked at their blog and it was like a real person and they just were basically like bragging about how they were able to make all of these open source contributions just by having an LLM do all the work. And so, but yeah, so I didn't know, I'm torn between the idea of discouraging new contributors and also trying to be economical about our time and our resources, because if we wanted an LLM to solve all of our issues, we can just ask the LLM ourselves. I think Google internally does not rate limit me on how much I use our LLM, so that's nice. But I've stumbled upon LLVM's AI tool use policy, which I think they have this problem at a much bigger scale. And so I basically read through it, agreed with it a lot, and then copied it over to our project. And I was going to sort of like wait to see if people had any comments on this. But I just ended up optimistically merging it because I kept getting people, random students from India trying to contribute. And so now when I see that, I will point them to that policy before, as my first interaction when they say, I want to try and work on this issue. But yeah, I am interested in what folks have to say about this situation. And if you've read through the tool use policy, whether you have any tweaks you want to make to it. It basically says like any issues tagged as good first issue are forbidden from using AI tools because the point is for you to learn something. And if you just use an AI tool, then you're not learning anything. But everything else, it's sort of a best judgment. Is your use of the AI tool being extractive on the time of the maintainers and the community, or is it, beneficial?
I think
Yeah.
as a very simple rule of thumb, if you are here or you are watching this on YouTube, probably you using a bit of AI in your coding is not the issue. The kind of the contributions that I think we're concerned about are exactly the ones that don't really care about what HEIR is and what it is and what it's trying to do, and just are looking for quick, easy, in quotation mark, issues on GitHub. So yeah, hopefully this doesn't slow down any real contributions, even if you do use some AI.
Yeah, I think that's a fair statement. I think we just want to know who you are and why you're contributing. And so we know that we have a real person who's interested in learning and our reviews are going somewhere. I will say AI is somewhat decent usually at writing file check tests. So if you're really annoyed writing those, use it for that. I use it for that.
Yeah, I think that's the biggest thing that our team is really leaning into, what this open source project is leaning into. AI can be a great tool that can help a developer, but the developers that we're looking to work on this project are really interested in the technical details of what we're trying to do here. And so think of this as an opportunity to grow your knowledge and understanding, working with a team that works in this every day and balancing them together. There's a lot of things that we've developed as engineers over many years that make our lives faster, build systems, all kinds of things that make things go faster than when I started years ago. AI is another tool, but it needs to be used as a tool. We know that it can make mistakes. We know that it can have some questionable things, and we expect the people who are developing this code to be able to critically look at that code and understand where the gaps are and where the wrong assumptions are going in. So our biggest engagement is we're happy to work with you if you're working with those tools, but we expect you to be engaging with the project, the math, the compiler, and all of the details and learning about this area and not just, again, to Jeremy's point, we have access to some of the best-in-class AI tools and we understand how to use them and we can use them. We're looking for people who are interested in getting involved in the project as a academic and industry intellectual partnership.
Yeah. And if AI is the reason that you can submit a PR to fill in a gap of something, then use it for that.
Yes.
So yeah, anyone here who's listening, it's really probably not a concern. But yeah, feel free to comment on it or discuss it and update it too, or whatever. So it's an open discussion and we're figuring it out. And then onto just like a short, just fun update thing, so that we can coordinate who's going where and meet up in person and chit chat about that. I think, March 22nd, maybe, yeah, that's probably the date, is at ASPOS, there's a tutorial co-located with it that Jianming Tong is hosting, and we'll also be co-organizing like a HEIR tutorial in that session. So that's on, I think, cryptographic accelerators or primitives. So if you're interested in the space of hardware accelerators and cryptography, that should be a good one, I think. I don't know, is it on the website? There's a fun what do you call it? Keynote speaker. So maybe it's not.
We got Craig to agree to do the keynote for that one.
Yeah.
Suggestion.
And this is hosted, I think this is in Pittsburgh, right? So if you're close to the Pittsburgh area or you have collaborators that are going to be there, then definitely keep an eye out for this workshop. And you know how to get in touch with Jeremy. So if you see him around, I'm sure you will. It's probably not that huge of a tutorial. Yeah, come chat. And then the other one is FHE.org. It's March 9th or something. In Taipei, co-located with Real World Crypto, and I think Hacks is Hacks the day before.
It's the 2 days before FHE.org, and then it always clashes the hack day at Hacks with FHE.org.
Gotcha. So I will be at FHE.org for sure, and then therefore I think like a couple days after, and maybe like the afternoon before or something. So if anyone wants to chat with me or work on something, I'll be there and would love to do that. And we also have a HEIR ML pipeline poster there, and then Voucher's also presenting a poster on HEIR and the FPGA accelerator. So there should be some good stuff there. And then Alex, I believe you're also going to be at Hacks and FPG.org. So
yeah, I'm not sure if I'm going to be at Real World Crypto because it's already like quite an intensive couple days, but I'll definitely be at Hacks, FPG.org, and maybe around for a few more days after.
Yep. And yeah, we'll get together and chat too. And I would love to hear like kind of how things are going at that point with starting work at Belfort. So we'll see how things are going. And I think also Florent from Optalysis is going to be there. So if you're going to be there, feel free to message me if you want someone to chat with or be with at the conference. And I think that's it on our radar. Oh, there's also HES, right? HES is going to be like, I don't know, 2 or 3 days before that or something in Seoul, but I am personally not going. So, okay, Alex isn't going either. I think some of the other hardware people are probably going, but HES is also the day before. But yeah, we won't be there. And so tell us how it is if you are going. Anything else on anyone's radar? I just wanted to basically shout out that Jeremy will be at AskBoss, I will be at Real World Crypto, and Alex will be there too, and Voucher will be there. So, yeah.
Yeah, the thing is, I got a medical thing, so I'm probably not coming to FHE.org this year, sadly enough.
Okay. I'll follow up with you offline though if you need some support with the poster or anything.
Yeah, that will be fine. That will be fine. That's ongoing work as always.
Okay. But just to make sure. So I'll be there in case anyone needs any support. So, okay. Any other topics up for just open discussion? Curious if anyone's curious about other things going on. I know we are like heavily focused on that one, CKKS ML pipeline stuff right now. And that's not to say there's plenty of other stuff going on. Going once, going twice. Okay. Otherwise, I'm going to go drink a ton of water. I'm tired of talking.
Thank you, Azra. Do you want to stop the recording?
Yeah, we'll do.